Mr. Sunder Chakravarty, and the topic for his presentation is Precession of Equinoxes and Sun's Transit in the Vṛddha-Gārgīya Jyotiṣa. He still has a minute, so I thought I'll just help you out with the brief introduction of Mr. Sunder. Yesterday, in fact, we had a brief actual introduction to his work through Professor Iyengar's presentation aspect. He is a student of Indian astronomy and Indian history of science. Works such as Aratantra, Vṛddha-Gārgīya Jyotiṣa, and Vedanta Jyotiṣa, Surya Siddhāntic, and he is presently researching at CAHC, Jain University. He has co-authored papers in Sprinter with Professor Iyengar, and that's the topic that you can also see here. So, simulation, I think, and visualization would be a very involving way of understanding cosmology for any lay person. So, I think that's a very powerful mode of presenting the Purāṇic and Siddhāntic cosmology.
Good afternoon, everybody. I work with Professor Iyengar at CAHC, and this is a topic I've been working for some time and the paper published. So I just summarize the paper here. So this is a small presentation about 11 slides. First few slides will be some introduction to observational astronomy, and then the 3 or 4 slides about the content of the paper. What is Jyotiṣa? When I was young, I thought Jyotiṣam is about individual predictions. It's that's one aspect of it, that's a popular aspect of it. But Jyotiṣa, here we mean study of astral. It's a natural science, a study of celestial. Particularly the path of the sun, moon, and the planets in the background of stars makes is an important dimension of the study. And if you look at the history that's been mentioned through the day, it starts with observations, from coarse observation to fine observations, to a computational model. That is trajectory of the Indian astronomical sciences. Vṛddha-Gārgīya Jyotiṣa is an important work in this sequence, and it's a big text of about 500 verses. 5,000 verses, my apologies, and spread over 64 aṅgas, some main and some upangas. And CAHC has already published 7 critical edition with 7 chapters, spanning the first and the second chapter. For this talk, we're going to talk about, I'm going to touch on Ādityacāra and Ṛtusvabhāva. Both of them cover the sun's transit through the nakṣatras. One is in the 11 sections, the other is in the 59 section. So this, just to set some background as to what ayanā means, what uttarāyaṇa means, dakṣiṇāyaṇa means. So this picture basically, if you are an observer looking east through the year, and if you observe the sunrise, you will see the sunrise in the extreme south here, which is the uttarāyaṇa point, from where the sun starts journeying north. So this whole journey is called uttarāyaṇa. In the middle, the sunrise due east, which is the midpoint, which is the equinox, which is a kind of a 0 point. Then it goes to the extreme north, where from there it starts the southern journey. So this there are 2 ayanas per year, and the midpoint of the ayana when it's moving northward is uttarāyaṇa. And by convention, we also have there are some numbers given here so that we have some quantitative feel for this journey, and also we can do mathematical analysis on top of it. So currently, the vernal equinox is taken as 0 degrees, and the uttarāyaṇa, the winter solstice start, is taken as 270. This actually it's an important event throughout many descriptions where the year really starts at when the uttarāyaṇa start of the winter solstice. So ideally the should have been 0, but all this convention has stuck, so we are just sticking with that convention. Slightly busy slide, but the other thing you want to understand is what are nakṣatras. So I've been struggling to try to answer that, but it's you can think of them as zones in the sky, and also you can think of them as stars in that zone of the sky. So there are the zones are the stars in the ecliptic belt. The ecliptic belt is a belt in the sky through which the sun, moon, and the planets pass. So they don't pass through everywhere. So the small belt in the sky through which they pass, and they contain one or more constituent stars. So in this picture, you see these are the nakṣatras. So it's the Dhanishta, Sutabhisha, and all those things. These are the nakṣatras that are marked here, and these are the constituents taras in it. So we are trying to show that the clean definition of nakṣatras is a good abstraction to have, but in reality, it is consisting of many individual stars spread all over the place. To an observer, this is the nakṣatra. To a mathematician, these segments are the nakṣatra. So we got to struggle with those two definitions side by side. And of course, there's a clock dial here, there's a clock model here. So the sky can be thought of as a clock with the sun as the year hand and the moon as a month hand, something like hour and minute hand. And of course, the sun does the uttarāyaṇa and dakṣiṇāyaṇa cycle per year. And the moon actually covers this whole round in one sidereal month. So the clock analogy fits very well here. And the sun is the Ṛṭukāra. He makes the seasons. As he goes along, he makes the seasons one after the other. There are 6 seasons mentioned here. And there's something called precession. I'll come back to later. So you want to keep this picture in mind. And if you look at the text, some nakṣatras are clear. And in terms of, we know what the constituent taras are. And some have some ambiguity. So a lot of papers discuss this. Later, Iyengar, Professor Vāya also done it, and Saha published this. Of course, our ancient texts, Parāṣara, Vṛddha-Gārgīya Jyotiṣa, and others also have sufficient information for us to make reasonable estimates of what these taras should be. So this slide is to understand the precision. Let me see if we can just show a picture first, and then I'll come back to. Okay, so I don't know, this can go back to that. All right, I got stuck here. Anyway, I'll continue here. So this is the globe. This is the celestial sphere that we mentioned earlier today. And this is the point, the easternmost point that I talked about. Assume this is the easternmost point of the sunrise. Now, if we track the easternmost point of the sunrise over many thousands of years, so in the year 2000, this was associated with uttarāyaṇa nakṣatra that went along with it. Around 0, it was Ashwini. Around 1000, it was Bharani. I think that in the current phase, it's around minus 2000 is Kritika. I'm sorry, it was negative thousands. So in the current time, it is Uttara-Purāṇic. So if you look at it, the equinoctial nakṣatra over the period of time has changed, and that is due to the precession. The precession is basically the Earth. If you think of Earth as a globe which is spinning, you can think of it as a top which is spinning but also wobbling. That wobble causes the pole star to change. So, and this poles, correspondingly, the equinoctial star will also change, nakṣatra also changes. So if you look at it, the pole star also has changed from in 2000 the current time it is in polar days, and in 5000 years ago it was pointing to 1. So this precession is an important phenomena that we use to date the text that we have. I just mentioned about nakṣatras. We saw the nakṣatras as a clock and a dial, and this is a listing of the nakṣatras. And over each nakṣatra there are constituent taras, and then all the nakshatras also have shapes of astrographs, and these can be inferred from Vṛddha-Gārgīya Jyotiṣa, Precession, among these are the Vedic texts, and Shardula Karnavadana is a Buddhist text, and Surya Chakravarty is a Jain text. So these texts also have information largely aligned with some differences, especially with Abhijit, which is dropped in the Vedic text but continue to live in the other traditions. And if you look at Aślesha, for example, Aślesha is a shape of a flag or a sarpa, and you can see that shape here. Rohini is a shakata, which is a shape of a Vedic card, a triangle. Maga is a koshtana, which is shape of a enclosure or a room. So some of them were very apparent to us now, and some, because we don't have the cultural connect, do not match, but we can imagine them to it. So this is the first, the Ādityacāra chapter, the earlier chapter, and here, let me see. This. So Ādityacāra chapter, the 11th aṅga, has 6 mantras or shlokas, which are very nicely tabulated information regarding the relation of the seasons with the nakṣatras associated with it. And they're also slightly more specific instead of being nakṣatra, they also say nakṣatra begin, nakṣatra mid, nakṣatra end. So they will, if you look at this Shravishadini Tatvari, Paushmardancha Divakara, it basically says from Shavishta beginning to Revati mid, Shishya Rita, which translates to 270 to 350 degrees in our convention. And we just break down the whole shloka into this range. So this gives us a clue of what is the marker for the season, and what is the marker for all the 6 seasons with respect to these nakṣatras. And for each of the nakṣatras, we already know the constituent stars and the proxy stars. So this gives us a way of dating this not with respect to one nakṣatra, which is typically done with Dhanishta, but with respect to 9 points. And so we can get a better estimate of the date with the lower error bands. Incidentally, the same information is also in Parashara as prose, and there the 6 ritus are mapped. Actually, it maps 6 ritus to 4 of nakshatras, and using 6 bright stars. And using that, the professor's book has dated this band around 200 years. This is based on the visibility, and in our approach, we have taken a slightly minimizing the error approach. So we are getting an improved error band of around 50 years. And we have, in our approach, we have considered the 9 seasonal nakshatras pointed here, the 27 proxy nakshatras that were in the table, and also all the 83 constituent stars. We're trying to figure out if the numbers converge and see which one of them fits best. There's a bit of math here, but I just, because I put some effort, I left it here. But the idea is to find the best fit method to find the epoch where most of the stars mentioned in the text of the nakshatras are in their prescribed seasonal span. So that is the problem statement. And for that, we define an error measure. The idea of the error measure is to see if the nakshatra, if the taras of the nakshatra fall in their band, they're considered to be perfect fit. If they're outside the band, then the nearest boundary, the distance to the nearest boundary is taken as the error for that nakshatra. So using that measure for multiple epochs from minus 2500 to 500 in steps of 50 years, it measures the error for each of those 83, 27, 9, and 27. Iyengar, I'll come back to that in a bit. But different sets of stars, we kind of measure the errors, and they all beautifully converge into somewhere around 1250. So this chart also explains the same thing but slightly more visual. The red indicates that more number of nakshatras are in their seasons. So as you go further and further away, most of the nakshatras don't fit in the season mentioned in the text, as we come around this band, there is a maximum fit. The Swati and Uttarāyaṇa are a couple of problematic nakṣatras don't fit. The rest of them fit very well. So we take it that this particular the earlier shloka, the Ādityacāra chapter is around this period, 1250 BCE. Let's have a few more slides. So I mentioned Iyengar there. So Iyengar has published a paper where alternate stars for starting from Abhijit, Dhanishta or Swarishta, and Shravana are taken. And so if we just to make sure that this dating is sensitive to that description of the nakṣatra, those arguments are also valid. We plot and they also come with the same region. In fact, there's another plot that is slightly more complicated escape, but it goes back to a little bit before also.
What is the original source for 83 stars?
I'm adding at the list. Also, the text of Parasharatantra, Vṛddha-Gārgīya Jyotiṣa along with the astrographs and the relative positions. So we have taken those things.
But these 83 stars should be considered along for these constellations. I mean, for those 83 stars, why not 85 or 2, 2, 3?
So this Parasharatantra, Vṛddha-Gārgīya Jyotiṣa is the source for this.
No, brightest stars around the 60. Is it not true? The bright stars
No,
around
there
the
are certain number of stars mentioned for each constellation.
Right.
Does that add up to 83?
Right. That adds up to 83.
or-
It adds up to 83.
And now, when you physically identify them with the stars as we see them today, it will be only 83, or there can be more stars which could fill in that place.
No, in our approach, it will be 83. If you physically see, I have not done the whole 83, but I'm fairly confident it will map up to 83. I'm not validating each one.
bright stars around the ecliptic, isn't it? Which can be assigned to various segments. Yeah.
The problem is this. The 5 texts which are there, ancient texts, all of them they give multiple stars. No, nakṣatras are not precisely 27 discrete 18.
No, nakṣatra division, I'm saying. Nakṣatra division is that. And so the bright stars around the ecliptic, that is an independent thing. Ecliptic is a circle. So in that, let's say 83 bright stars are there very near that. So then.
No, they don't do like that. If they were like that, they would have been different. The way that we have understood is that 83, the basic things have been selected due to moon's position. How it was done is not very clear. But each constellation says, for example, Rohini, they are very clear it was 5 stars. It is the bright star is Aldebaran, but the others are above that, And they wanted a triangle to get formed, like the Vedic Soma Yaga. That is what it says. So similarly for Maga, it has to be like a koshka, like a room. And for Jeshta, it has to be like
Mala.
see, the Jain say it has to be like a Gajadanta, like it has to be an ivory stake. And for Ashklasha, it has to be a hood there. So it is not the brightness, it is the figure they have taken when they were rising. And in Parasharatantra, it gives the directions of the northeast, there is one star, southeast, another star kind of. Our identification may be slightly wrong, but by and large, that is what we do.
So what is the relation between these names and shapes? For Magha, you are saying that it is like a room coaster, but I don't see any relation with the name and
Any relation between?
names
there
and
is
shapes.
name and shape.
Name and shape.
But that is
This
the
text is the shape mentioned. I think,
Why?
what is
No,
that?
It is not mentioned, in the text it is mentioned, Vṛddha-Gārgīya. And
No,
Vṛddha is a name for Maga, an alternate.
Why?
No, because those 5 stars, 6 stars, if you join them, they look like a room.
But why Makha?
everybody has every imagination. So it can construct so many things, but that is okay. But why it
I
is
can't
not?
answer all the way.
No, if it is like a room, Koshka, the question is why did they name it Makha?
Then they could have made it the cost of
That is the Vedic name. And that is here. It looks like that. You identify the Vedic star, Magha, Piturdaivatam. Then the Jyotiṣa books, Vṛddha-Gārgīya and Aratantra says that it is made of 6 stars, which looks like a koshka. That is what it says.
It must be somewhere else in the Vedas that we have missed it and.
Yeah, it's possibility. In the Kapishtal Samhita and the Katha Samhita, there are more astronomical statements than in the Taittiriya. Maitrayana also has more astronomical statements. That will have to be searched and found. We are not yet, we are doing that. You please proceed.
See, it is said that only Vrishchika has a natural,
Yeah,
but we can directly see. Others are all imagination.
No. See, Jeshkar, I think he showed that figure.
Oscillation is like the snake. And that, I can convince myself, it can be drawn. There are few that match very well, and few I think because they are culturally so far apart, we are not able to imagine.
Okay.
This takes us to the second chapter, which is the Ṛtusvabhāva. This is a much later chapter in the book. And here, this is an interesting description of the sun's path. Here it mentions for the sun's path is mentioned in terms of 12 Vaidika and 12, they're equivalent Laukika names. Madhu is mapped to Chaitra Masa, and it is also tells you the nakṣatra and which they belong. So Revati. So all these 12 months, both the Vaidika months and the Laukika months and their corresponding nakṣatras are given. So instead of the 6 partition here it's a 12-part here. And also the nakṣatras are plotted here. And we did the same kind of minimization of error of information, for this information that was given, and this red line shows it. And this particular shloka they show around -500. So the interesting part is, that the season, the transit to the sun is given in 2 phases, but they seem to be about 800 years apart. So this leads us to think that this Vṛddha-Gārgīya Jyotiṣa is a compilation of knowledge as we go along with with a refined model as time progresses. And in Ṛtusvabhāva, of course, the Ritu sequence begins with Vasanta non Shishira. That is in the way they describe. So there seems to be some movement for the start of the year pointing to Vasanta from Shishira. And the Ritus, as I said, related to months, not the nakṣatra span and boundaries. So this looks like slightly more refined way of or small grain time description. And of course, Shravishta is past its time, whereas Shravishta was at the beginning. So this is a hint of the precision. And this is an important conclusion that Professor has made. The 12-month solar zodiac obviously in intercalation emerges. So the solar zodiac can be seen here. It is not something that somebody else has to tell us. It's already mentioned here very clearly. There is no doubt at all as to what this is. So in closing, there is a progression, in the early Vedic text, the 2-ayana Siddhāntic system was there, that those can be thought of around -1700 BC. And of course, we did the Ādityacāra around 1250 starts by having a Purāṇic nakṣatra per season. By the time we are Ṛtusvabhāva, it is a 12-month solar cycle. VGJ is layered. And of course, this is what we wanted to highlight, the solar zodiac references for that in unambiguous terms is available in Indian tradition. I am happy to answer any questions. Thank you.
When did this Vedic month names change to this Chaitra Vaishakha? Can we know when they identified? I generally think it believe because the Purnima happens near that star, right?
Yeah.
So,
the dating of it is a problem to be solved. But this is, in my mind, the first textual references where these months are used in the solar context. So these months are used in the lunar context compared as earlier, but in the solar context, this is the first time it is used. When it was origin and what is its relation to the nakṣatra with the full moon, There are some speculation, but I don't have firm answers. It's a good question.
So, I mean, so am I right in I'm understanding in the following manner? Your assumption is that, rather you didn't say this, but normally it is believed that all these zodiacal division, Mesha, Vṛddha-Gārgīya, etc., is borrowed from the Greeks. Normal, I'm not saying you. So you are saying that no, actually this zodiacal division is associated in Indian texts much before the any possible borrowed from the Greeks. Am I right in understanding?
No, it comes from Mesopotamia.
Yeah, exactly, that's what. we're
This is
trying
what
to
you want
say.
to tell?
Yeah, want to little bit elaborate on what you said. The zodiac, solar zodiac, if that is what we are talking.
Yeah.
As it is understood, it is the movement of sun
Yeah.
in relation to time on earth for human beings. How much he has moved there in relation to my time here. Initially, they were all the felt seasons. The Ritus were felt, summer or winter, other thing. If you compare the east and the west, as you are telling, the Babylonians had only 4 seasons. They have the solar zodiac around the same time.
Yes.
At least that is what Vṛddha-Gārgīya and others have given. They have 4 seasons. They have 6 seasons. This 6 also is not original. It is the 2 that is Maitreya 2 ayanas is the original, because there it is said Saumya and Agneya. They felt feeling the human beings. Yesterday I mentioned about the Kala. The Kala continues the description of Kala in that, and then it goes to these descriptors. I could not cover that. No. Whereas here it says, then it becomes 12. In between there is one Chaturmasya. That is also a zodiacal system of solar zodiacal thing. So it is 2. Then Chaturmasya 3 divisions. Then it went to 6 divisions. Then it became 12. The Jains have still maintained their Chaturmasya divisions as it is. So this is the difference. So the
Chakravarty means the
4 months,
3
parties. The Babylonians had 4 parties. They never had 3.
No, even Greeks had on before.
Yeah, only four parties.
Ashokan inscriptions talk about 3 divisions of 4.
Sorry.
Ashokan inscriptions have 4-month divisions. 3
Yeah, there is the
to 4.
Chaturmasya. Chatur.
But you have to keep in
Next.
mind.
12th division of zodiac in Babylonian is not before 6th century BC, sir. Because Mulapin, I think the last Meshadi, we won't find it.
We'll talk about it later.
Yes, sir.
Thank you for that presentation. I was seeing of the fitting with the minimum error you are searching for, and I can infer that the error bar is less than 1 degree, I think, in the vertical direction. 1 degree error bar could be there. My question is, are you, because of the long time span, 2,500 before Christ and this kind of, so it's 3,000 or 4,000 years ago. Are you taking into account the proper motion of the stars?
Yes, so a good question. So proper motion is taken into account. The data is being harvested from stellarium. It's not computed based on precision. But I found out that computation based on precision is very lazy and reasonably good data. The proper motion doesn't contribute too much except for a couple of nakṣatras, except a couple of stars. So proper motion, while its point is valid, doesn't contribute to any significant additional error there.
Because it should be about 3 degrees or something like that, the proper motion.
3 degrees probably not. Maybe in case of Swati, it may be of that order, of that degree plus order, but for others, it is not of that order.
So it's not moving the dates.
No, actually, precision causes a lot more drift than the proper motion.
Proper motion, the latitude becomes important.
Yeah.
But we are not considering the latitude. And in fact, that may have some effect on observation of planets in the nakṣatra system, which of course is a different aspect altogether.
Yes, I was thinking before when we were thinking about the big digger like a clock. maybe in that case it can change because on 2-3 degrees that, the clock can change.
Yeah, so
But
that is.
okay.
Yeah, it will.
Thank you.
Excuse me, sir. Sir, I have a question.
Yeah.
There was a discussion on the names of the stars. So can we say that one way of naming that based on the shapes of those stars? So another way, can we say that what are the experience on those days? For example, when I say Pushya, so even etymological meaning also Pushyanti asmin artha haiti Pushya. So when sun enters Ardra star, then rainy season starts. So Ardra, Punarvasu, Pushya, for these 3 stars, can we say that with this reason, these stars are named in this way? So is it possible? Is it
Tishya, I think.
yeah, but Pushya also is there. Pushya Tishya nakṣatra is the Pāṇini Sutra, and he gives in this way.
No.
Yeah.
We should not jump to Pāṇini from Vedas.
No, I'm not saying that this is the law. I mean, it is there in the tradition also. This kind of explanation of these names.
Yeah.
It is there in the tradition also. Therefore, I just.
No, astronomers should not accept such traditions, is my argument. The Vṛddha-Gārgīya tradition, which in fact in the morning, I think, M.D. Srinivas in one of the slides they showed, Vṛddha-Gārgīya, they, justify anything by Pratyayat and this argument, that argument. But astronomers should not do that, he says. I avoid it, but that's it. It is just a joke.
Yeah, but I found that those names or I mean those reasons also convincing. Therefore,
Necessary. Because it's pre-Pāṇinian names.
Yeah.
These are all pre-Pāṇinian names. So when we know that Vṛddha-Gārgīya was minimum 500 BC, the names, why unnecessarily take it up? They would have done something later. Tishya, what you are telling, is a single star as per the later argument. But Jainas and Buddhas have 3 stars. And it is given a shape also like a Sharava. Whereas there is no shape for others. And you see, the Pushya is like a crab, There is a cancer. There's a very important thing. You can see the thing, it looks like a crab. But in the Sanskrit names later on, it is only a single star. Why the shape itself is not taken there if you take the single one. But the others have taken the